Okay. Thanks everybody for joining. We have 4 presentations this evening, and then tomorrow we'll have 3, and then Wednesday we'll have 4. So I will put the link to the peer review into the chat here in a little bit, and so that everybody has that link so that you can fill out an evaluation for everybody else in the class. You have 25 minutes to present and 5 minutes for questions. If you go a little under, that's fine. Please try not to go over so it doesn't throw off our schedule. For questions, since it's a pretty small group, feel free to unmute yourself and ask the question, or you can type the question into the chat. If the question is in the chat box, please the presenter, can you please read the question before answering it? That way it gets captured in the recording. I am recording this, so and I'll record all 3 days. So if anybody can't attend these live, then you're welcome to watch the recording so that you can fill out those evaluations. I think that's everything. If you have any questions, you can chat me privately there in the chat window, and we will go ahead and start. Kelsey, you can go ahead and share whenever you're ready.
It's coming.
Okay.
That's good.
Good.
Yes.
Okay. Good evening, everyone. My name is again Kelsey Calvé. I'm an environmental scientist at Freese-Nichols, but more importantly, I'm a graduate student through the Penn State program, of course. And this presentation is on my study through 596A, which is focused on the water chemistry of the Gulf Coast aquifer. And I'll just add a note real quick at the start of my presentation that Dr. Gartner and I have been working on this since the beginning of the summer. So I'm going to go through my intro, my methods, and my results. But then the discussion piece is kind of what I'm still working on and wanting to submit to a journal in December. So that's kind of my timeline. Okay, so in Texas, we have a state agency called the Texas Water Development Board, whose mission is to monitor the levels and the quality of aquifers throughout the state. They do this through a monitoring program, which has been, I think it started back in 1907, and they monitor different water quality parameters and chemical compounds at about 10,000 groundwater wells across the entire state. So it's a huge data set that they have made available to the public. In terms of what they monitor, they look at water quality parameters, including total dissolved solids, temperature, pH, really anything that is describing your water. But they also monitor about 33 different chemical compounds, including arsenic and fluoride, and lithium and boron. And some of those are naturally occurring in groundwater. However, once they meet or reach a certain maximum contamination level, then they can cause health concerns if there's long-term exposure. So that's really the emphasis behind the Water Development Board's mission, is to look at those chemical contaminants and the overall water chemistry of our aquifers within the state. And so the focus of my study is the Gulf Coast aquifer. This includes about 3,000 private and public groundwater wells with those same water quality parameters and chemical compounds that have been monitored since 1907. So still a really big data set that I was able to work with. And my interest was studying what the drivers of groundwater contamination are for the Gulf Coast aquifer specifically, using the board's data. So again, my study objectives, I wanted to evaluate that full suite of chemical compounds for the entire Gulf Coast aquifer. And in order to, try to determine what is influencing or driving groundwater contamination, I needed a dependent variable, or a variable that's going to help me predict that contamination. And so I did quite a bit of literature review for this, and I ended up landing on total dissolved solids, or TDS, which is one of those water quality parameters that the board monitors for. In the literature, I was able to find TDS has been used as an indicator for groundwater contamination, And so it fit my study really well in terms of looking at those different aspects. And then this is jumping ahead to the results a little bit, but I want to go ahead and highlight fluoride so that y'all have a background on this. So fluoride is natural in groundwater. It also comes from anthropogenic sources, including oil refining and fertilizer plants with agricultural practices. It has beneficial effects for humans in terms of, dental health. You do want some amount of fluoride in your water, but it does also have harmful impacts if it meets a certain maximum contamination level. And those can lead to, liver damage, brain damage, even DNA structure changes. So it is certainly something that is monitored very closely. And then Texas is already known as a state that has high concentrations of fluoride in our groundwater. So this is already on the list of contaminants that are being monitored. Okay, before I move back into my study objectives, I want to give y'all a little bit more background on what I was analyzing in terms of the influencers of groundwater contamination. So land use impacts was something that I looked at as a driver of contamination. And in general, if you have increased land development, including, urbanization or increased agricultural practices, you can make the assumption that you're going to have a decreased supply of groundwater from either irrigation or from municipal or residential use of those groundwater resources. So, increasing pumping from the aquifers. Also, if you have impervious surfaces, that's leading to less infiltration of surface water resources back into the aquifers. And Texas has been in a drought for a while, so we're already working with depleted groundwater resources, and increased urban development, increased agricultural practices. That's just leading to a greater demand on our groundwater. In terms of climate's influence, was really climate was the other driver that I looked at for groundwater contamination. In terms of its influence on groundwater, you have climate change happening across the globe, across the US, certainly here in Texas. You have less precipitation and less recharge going back into the aquifers. You also can make the assumption that you have decreased soil moisture and increased runoff. And therefore, again, you don't have as much stream flow or surface water resources going back into our aquifers. So we're kind of having this intensification of the water cycle occurring as we see climate's influence on groundwater. Okay, so back to my study objectives and kind of why I just gave you a quick little background is my question was, what are the primary or secondary drivers that are affecting groundwater quality and thus groundwater contamination? Again, my dependent variable in my study was total dissolved solids, and my explanatory variables, which I'll explain here in a second, were land use as the primary and climate as the secondary. And I say primary and secondary, I'm kind of using those words really in terms of just my study specifically, because land use has been so extensively studied in terms of linking increased urbanization and agriculture to contamination of groundwater. But what hasn't been studied is really those climate drivers. What's happening in the background that is causing, further accelerating or further causing this feedback loop in terms of groundwater contamination. And that's where I think my study was a little bit more unique and where I wanted to focus. So I'm going to talk about two different models. The first was the land use model. And the variables for this model included land cover from the National Land Cover Dataset for 2019, as well as groundwater quality. And when I say groundwater quality, I'm referring to those 33 different chemical compounds that the Water Development Board monitors for. So you can see, if you're not familiar with the Texas landscape, that in the northeast counties, we have a much greater percentage of forest or herbaceous cover, such as wetlands. And then as you trend to the south, you start seeing more agriculture, as well as more urbanization. And I want to point out, in my previous slides, I showed those groundwater wells as point locations across the aquifer. Due to just how many different data sets and information I wanted to include in this study, I averaged everything up to the county level. So that's how you're going to be seeing this data presented, is at the county level. For my second model, I looked at climate variables. So I looked at soil moisture, drought severity, stream flow, groundwater recharge, precipitation, and then also those 33 different chemical compounds. These came from a variety of different sources, including USGS, including Terra Climate, as well as the PRISM Climate Group. And you can see from just the trends and the raw data sets that we really have a concentration of soil moisture, precipitation, stream flow and recharge in those northeast counties. And if you'll remember, that's also where our forests and our herbaceous covers are concentrated as well. And then drought severity, you see that darker color in the southwest counties. That's kind of just a indicator of the landscape of Texas, but that's also, again, where we're seeing a lot more agricultural practices, and where you could, make the assumption that they're pumping more water out of the groundwater for irrigation. Okay, so really getting to the meat of my study and to the methods. In order to evaluate all of these different variables for the land use model as well as the climate model, I looked to the exploratory regression as a starting global model to evaluate all these different variables across the landscape. So the exploratory regression took all the different variables for the land use and the climate model, and it looked for certain certain significant relationships. It looked for redundancy of the data, for bias, also performance of the models. And it provided or generated passing models that met all of these criteria. And then those passing models were able to then be further evaluated. I'll mention real quick for my study, a p-value of less than 0.05 indicated that we had statistically significant relationships, and that was one of the checks. And then an R-squared value of greater than 0.65 was indicative of the goodness of fit of the model, and also was a check that, all of these different variables had to pass. So the passing models that came out of the exploratory regression were further analyzed in ordinary least squares, which is another global regression model that allows you to check your data for, again, those 5 factors: the redundancy, the completeness, the bias, and allows you to further identify or further substantiate that you are seeing statistically significant relationships, you are seeing a goodness of fit with your model. So this really provided just a whole bunch of more parameters and checks for the data that I was looking at. The last global model was spatial autocorrelation, or global Moran's eye. And this allowed you to look at the trends in your data set. So are they dispersed, are they random, or are they clustered, meaning that you have a positive Moran's eye? And my data were clustered, or at least the model that I analyzed further. And so I was able to move further with that one. And I'll mention also that each of these models are within the Esri spatial statistics toolbox. And so each of these were done within ArcGIS Pro. So the last model was called the multi-scale geographically weighted regression. And this allows you to look at your variables in space or within a geographic framework. So it allowed me to take the passing models, which I'll show you in a second, that met all of the statistical checks and criteria, and actually look at them across the Gulf Coast aquifer at the county level and apply that geographic context or framework. Okay, so for the climate model, these were the passing models that came out of the exploratory regression that, again, met an R-squared of greater than 0.65, met a p-value of less than 0.05, as well as some other statistical criteria that were looked at. This was really exciting. I was thrilled to see this many passing models come out of it. I thought it really started to tell the story about what might be causing groundwater contamination, or what our drivers are for the, across the Gulf Coast aquifer. Once I put all these models into the ordinary squares and the spatial autocorrelation, the one highlighted in red or orange is the only one that passed all of those checks. And so this one is essentially indicating that where there is high TDS, which was my dependent variable, we're also seeing high fluoride and decreased or a lack of stream flow. And I'll get into those results in just a second. For land use, again, all of those variables were put into exploratory regression, and these were the passing models that came out of the exploratory regression. It was really starting to tell a story, but once I put all of these passing models into OLS and spatial autocorrelation, that's when only the top one, which is highlighted in orange, came out to be what I could further analyze, which was when we're seeing increased TDS, we also see increased fluoride and a lack of forest. But still very interesting, still something that I think was worth moving forward with. So this is just giving my workflow. I know I am throwing a lot of information out there, but the variables are at the top for the climate and land use models. Those were all put into the exploratory regression, which then provided different checks for redundancy, significance, performance, and bias. And what came out of those were two models that passed all of the checks and met all the criteria, which were fluoride and stream flow, and then fluoride and forest. And then those two passing models went into the multi-scale geographically weighted regression, and that's when you're actually able to apply it across the landscape or apply a geographic context to your data, which is really exciting to be able to see the trends in terms of the R-squared value, which is indicating your statistically significant relationships. Okay, so this is where I'm at currently within my study, is the results or the discussion. What do these results actually mean? So for the land use, this figure is showing the multi-scale geographically weighted regression results, and you're seeing the R-squared value or the relationships between TDS, fluoride, and forest. So you're seeing that TDS and fluoride are highly correlated. There's a high R-squared with those darker pink and maroon colors in the Southwest counties, or at least trending down towards those Southwest counties. We also know that there's a lack of forest in these counties, and that's both due to the natural landscape of Texas, but also due to increased development and agricultural practices within these areas. And I did a lot of literature reviews and studies on, what does this mean in terms of groundwater contamination? That's where I'm at right now. But one of the primary things I've been able to grab out of that study is that forests and other herbaceous land covers, such as wetlands, are able to filter those contaminants before they reach our aquifers. So the more that we, decrease those land covers, we don't have that protective barrier between the surface and the aquifer anymore. And so the quicker those contaminants can get into our groundwater resources. For climate, this is showing the multi-scale geographically weighted regression results for TDS, fluoride, and stream flow. So again, you see the R-squared values, the relationships between the variables and the figure on the right, and you're seeing those darker purple or higher R-squared values in those Southwest counties. I think these results are indicative of what we're seeing overall in terms of climate change, especially in Texas. And, we've had less precipitation over the past 20 years, which I apologize if I didn't mention this earlier. My study was concentrated to 2000 to 2020, so over 2 decades. But we're having less precipitation, less stream flow, and also less dilution of those contaminants in the groundwater. So you can make the assumption, and there's literature out there that has made the case that the more recharge you have back into the aquifers, the water is able to move those contaminants a little bit more quickly out to the discharge locations. And again, I mentioned this earlier, but I think these results are really indicating the intensification of the water cycle. And so we're having that less infiltration of the surface water into the aquifers because we're seeing a more drier surface due to less precipitation and less stream flow. But that's currently where I'm at with my study, and I'm excited to keep moving forward with it. Thank you.
Great job, Kelsey. Does anybody have any questions?
Kelsey, it's Dan. Thank you very much. That's completely well explained through the statistical analysis, and your visualizations really show those trends by your dependent variable and then also the different factors. You've averaged 20 years into the counties, and seems like you made the right decision with that. In your study, will you look at it in a different temporal time period or would that be a follow-on type study?
Yeah, that's a great question. That is certainly something that we thought about. But I don't think that would be the case for this study. I think that would be a follow-on study. There is a lot of data out there, but it's a little bit difficult to find by the decade. I think the biggest limiting factor is the Texas Water Development Board's data. Although it goes back to 1907, not all groundwater wells are sampled in the same year or for the same chemical contaminants. So that is certainly the limiting factor that I ran into with this study.
Thank you. And 2 decades is really not that long at all, either in an environmental study.
Right.
Thanks.
Sorry, I had to write no pun intended because Dan said it was very well explained.
Oh, okay. Thank
My
you.
dumb humor. While we're waiting for any other questions to come in, as someone who has a well on her property and has a UV light and just kind of unaware of all of the things that are happening with that, did you, when you were doing your literature review and anything else, were there other states that were sort of comparable, studies that what you're doing, or what was happening in other areas of the country?
So I didn't necessarily look at other states, but that's a really great idea. My literature review, I tried to focus it to Texas, just because, in terms of trying to understand the geology of not only the Gulf Coast Aquifer, but really the state, it's just so complex and it's a little out of my area of understanding when I get to that level. So I did try to focus on Texas for my literature reviews, but there have been a lot of studies that have used the Water Development Board to link, again, land use change to contamination. And so I really wanted to broaden that scope and try to focus on these climate variables. But that's a really good idea to look at other states and see if they're doing similar studies and getting similar results.
Your reasoning makes sense, and it does seem like there are definitely some things that are very unique to Texas. Like I was just looking at a fluoride contamination map, for example, and it does seem to be quite high in the area that you're looking. And now some other states can look at the work you're doing.
Yeah.
That'll be a nice resource for them. Jim has a question in the chat.
Okay, Jim's question is, this goes beyond the scope of your project, but can you talk about the public policy implications of your findings? Yeah, that is certainly something that I'm really hoping to dive into more in my discussion. I think one of the biggest takeaways for me is when I look at, if I can go back, the results for the lack of forest. I think this makes really, in my mind, complete sense. I think it is really powerful to see these results in terms of the less herbaceous cover and less forest you have, and therefore less of a protective barrier. We're seeing, those higher contaminants in those counties. And I think when you think about land use change, that makes sense. But I think it's also reiterating to us that as we're continuing to develop cities in rural areas, we really need to be thinking about still including those covers in our planning. But that's a good question, and that's something I really want to think hard on in my discussion.
Great. Thanks again, Kelsey. Really good presentation. I can tell you've done a lot of work on it. So looking forward to hearing your results.
Thank you. Thank you.
And if you want to put your email address in the chat in case somebody else has a question for you, they can follow up.
Sure.
And you can go ahead and stop sharing. And Nick Walton, you can start sharing whenever you're ready.
Okay, all right, there we go.
Hello, everyone. Just give me a second here to make sure I know exactly how to share the screen.
Yeah, you should be able to kind of hover over the bottom there.
Yep. And here we go. Can everyone see that?
It's coming up. I don't see it yet, but other people might. There we go. I can see it. So, and I
right.
can hear you fine. So you're free to start when you're ready.
All right, I'm just going to move this bar real quick. And there we go. So hello, everyone. My name is Nick Walton. Of course, this is my Penn State MGIS peer presentation for 596A. And my project is over predicting development to plan for future sewer service demands in Oconee County, South Carolina. Some background on Oconee County, South Carolina. It's the westernmost county in the state. It's located at the confluence of the Georgia, North Carolina, and South Carolina border. It's about 700 square miles, but keep in mind about 50 square miles is water. We do have Lake Hartwell to the south, Lake Keowee and Lake Jocassee to the east, and the Chattooga River to the west and north. It's a smaller population, about 80,000, and is also home to the Oconee Nuclear Station with 3 active reactors. Now, why I'm focusing on Oconee County for my project is because I'm actually the GIS manager for Oconee County government. And we'll touch on this later on, but I am one of few GIS professionals in the county. One of the big things about my job is that I manage a lot of data sets around the county for different organizations. My project is focusing on sewer service. And in the county, 80% of our residents depend on septic tanks for their sewer needs. Of the 53,000 addresses assigned in the county, 9,707 are in municipalities, which are the main sewer providers. These municipalities include Seneca, South Carolina, Walhalla, South Carolina, and Westminster, South Carolina. For context of growth, I did say it was a small county, but it's growing pretty quick. About 13% of the addresses were signed in the last 10 years. And why I keep focusing on addresses as my point of growth and context is because I actually, as part of my job, assign all the addresses for the county and manage that data set. So that's kind of why I'm pulling that for my context. And this just kind of culminates with Oconee County is growing faster than its infrastructure. That includes roads, water systems, and sewer services. Now, why is it important to focus on septic systems? Well, overall, septic systems are a good way to deal with that type of waste for a lot of people, especially if they don't have access to a full sewer system. Just like DHEC, which is the South Carolina Environmental Agency, talks about how if a septic system is installed properly and maintained, it doesn't really have any major effects to the environment. Septic systems need to be inspected between 1 to 2 years and pumped every 3 to 5 years. You can already start to figure out where the issue is here. If you just get off a couple years off a maintenance schedule, you can start running into issues with the septic system. And that's up to the property owner. So you don't have an overall power coming down saying you need to do this. Poorly constructed and unmaintained septic systems can lead to groundwater contamination with pathogens, chemicals, and nutrients. So here is kind of the research reason. Oconee County, like I said, is growing very fast. Reasons for growing fast: low taxes, there are industrial incentives, it's reasonably affordable. We're right next to Clemson University. Depending on where you are located in the county, you're either going to be about 1 to 15 miles from Clemson University. And it's starting to become an outdoor paradise for a lot of people. Like I mentioned before, we have a lot of lakes, but we also have the Sumter National Forest. We have state parks. We have a lot of hiking opportunities and opportunities for people to be outside. As the Oconee County GIS manager, I have a unique position, perspective, and insight on the workings of local government and agencies and companies as well. If you look over to the right side, I have my table listing this is a few of the data sets that I manage. For Oconee County, manage the roads. For the city of Walhalla, I manage zoning. For Oconee Joint Regional Sewer Authority, which is the one major sewer provider outside municipalities, I manage lines, manholes, and lift stations. Prisma Health, which is our local hospital and overall health provider, I manage their ambulance and helicopter information, including landing zones and driving routes. City of Seneca, I also manage their water system, including their lines and pumps. And Blue Ridge Electric, one of our energy providers, I have their power line data. So with all this kind of coming together in the position that I'm in, I see this need for a comprehensive sewer service plan that starts with predicting future service needs. In the middle here is just a screenshot of an ArcGIS Online map that I manage showing active sewer system in the city of Seneca. So my project problem. Oconee County is growing faster than its infrastructure, particularly sewer infrastructure. To plan for future sewer infrastructure, one needs to predict future demands through future growth. To predict future growth, one needs a method of determining optimal locations that meet the criteria for future growth. Why? Current sewer service providers use the response method for growing the sewer infrastructure, particularly in the municipalities where they only start providing or thinking about infrastructure developments with, particular individuals requesting that. And that's well enough if you're within a municipality, but if you're not within a municipality, it's pretty much just says you got to go and use septic. And like I said, many people already do that, but that's another cost you have to think about for housing. Septic systems to put in, can be between $3,000 to $10,000, depending on if they need to be engineered or not. And you also have to think about the long-term consequences of that, having to maintain it, having to have access to it. A lot of people don't think about, oh, a septic system is placed in the ground, but you need a truck to be able to access it. And overall, sewer service across the county is extremely limited. Now, why me? I touched on this a little bit before, being I wouldn't say the central GIS provider in the county, but I definitely have the most data to look at and manage. I have this unique perspective to see kind of the geographic context of it. And also I am the map producer and product maker for the county and for the individual agencies, local governments, and companies. So I can give that geographic context to them and, look forward and not just be sitting here responding. Impacts of the research. Sewer providers can change from a reactive to proactive in infrastructure construction. The county can attract industry, commercial, or residential development. I've lived in plenty different places in the past couple of years, and a lot of places, really focus on the commercial industrial value of an area. And then after that, residents will follow. Oconee County is still a very small populated county. There's some reasons that there is a massive population because we are in the mountains, so there's limited ability to grow in certain ways. But there's other places that have that potential but just haven't yet. Overall, when you're talking about providing a service, the more people you have part of that service, the general cost of the service will go down. So that's why I included that point in here, is that current sewer providers, their costs can go down, but I haven't done the actual math behind that. I don't know how many it would be required to really kind of balance that out, but I do know from interacting with the different providers and with the joint provider that one of the reasons why they don't expand as much is just because of the cost of doing it. As I touched before, it's going to be a better impact to the environment because overall, when you have a closed sewer system, you can maintain it better. And if you have an overall agency, watching it, they have to constantly be monitoring it. When you have individual systems in people's backyards, there's no one there going out and making sure that's working properly. And on top of that, there can be abandoned houses or abandoned areas where there are systems back there that aren't being regularly maintained. This research can act as a catalyst for transportation, electrical, and water infrastructure. A lot of times if people say, you can't get sewer out there, then what's the point of putting anything else out there? And lastly, this research can build a foundation to establish a baseline for future comprehensive expansion plan. Without a baseline to build off of, it's hard to really go anywhere. Past research focuses on, I found a really impressive article in research that talked about study of non-urban to urban changes. It was studied in Raleigh, North Carolina, and it was a raster cell approach. And the really interesting thing about it is they established a baseline for the project, which was using the National Land Set Cover data set. And from that, predicted future areas of growth based on features of interest. So distances to certain features, the closer you are, the higher probability of potential growth. The further you are from those features, the less probability of that growth. And then they took that study a step further and put it into an R program to kind of generalize future predictions of areas based on the existing development. Why this study is important to my research is because it uses layers and baselines which are universal across the United States. Flood zones, distance to freeways, urban centers, population growth, and so forth. The data. Like I said before, I manage a lot of data, and that's one of the nice things about being in my position is that I have access to all these things, and they're regularly updated because I'm the one who's doing it. The baseline for my study is going to be the National Land Cover Database for 2021 from the USGS. And that's really an important baseline for me to go off of because it already does a whole lot of work at telling me what's already out there and already has it categorized. Down at the bottom here, we have Oconee County government where I work. And important layers from there are, county regions and polygons, road lines, addresses, points, boundary polygons. Preservation and zoning data is important too, because there's already areas that I know will need to be cut out of the general study because I know there's just not going to be development there. And then of course, zoning, we don't have a lot of zoning in the county, but we will have certain areas where you just won't be able to build or develop. Future sewer projects, population, and topography all are important areas that will influence my study because these are information that I can use to generalize where there might be growth. And then parcels as well. I don't use the parcels right now in the study, but I see the potential of them in the future. As long as on the side that we have municipalities, sewer lines, manholes, boundaries, and electrical services, all information that I can pull in and use as important determining this project. And then over on the right side here, I have information from the Joint Regional Sewer Authority. A lot of this information I'll use for the last steps of my project where I see where there's existing infrastructure and know that that can be built off as a predictor for where there might be future growth. So the basic methodology is broken down as such. Important criteria, including drive time to city centers, proximity to main roads, and flood zones, will serve as predictors for development. These predictors are used to create new raster layers in ArcGIS Pro. These raster layers are combined with the National Land Cover data set to provide areas of existing development, areas unsuitable for development, and areas that have the potential for development. Moving into my methodology, I have it broken down into simple steps that I've already started kind of marching through. Step one is to establish the study area. Here you can see the boundary of Oconee County, and I clipped the National Land Cover Database raster to the boundary of Oconee County, and that is the extent that I'm going to be using for most of the study. Well, I already talked about this before, but certain areas I know they're just not going to be developed. So protected areas such as national forest, state forest, and historically significant sites, they will be masked out of the extent of the Oconee County boundary because I don't see it worth going down that path because there's most likely not going to have development there. Step two is going to be reclassifying that National Land Cover database. when you pull in that database, it's huge. Of course, it's the full extent of the United States. So I already said I clipped it down, but it comes through with type codes from 1 to 95, covering all kinds of different land covers in the United States. You know, there's plenty of places in the United States that aren't similar to Oconee County, so that information is not useful to me. For here, I pulled out specific ones that I feel like would be important to the study. And that's what I'm using for my reclassification. And why I'm reclassifying is because later on, I'm going to be using a raster calculator to kind of add up the rasters to produce the future prediction. So over to the right, I have reclassification codes ranging from -5 all the way up to 5. And, you know, a negative number would be an area that does not have the potential for growth, or I don't believe has a potential for growth without major infrastructure or money put into it. You know, for example, type code 11 on the top here, open water would be a -5. But then on the other end of that, if you go all the way to type code 31, barren land, that would be a +5 value. Barren land, you know, excluding other influential factors, could easily be built on. You don't have to go through and bulldoze over forest, or you don't have to worry about open water or like wetlands down at type code 90. So it would just be, in general, areas that, if they have the potential for growth, have a higher value. If I feel like they're going to negatively impact that study, they're going to have a negative value. And this is an example of me running through just this reclassification of Oconee County. You can see red is the outlines of the lakes, pink is the outline of current development, and green is the outline of no development. Now, Oconee County is in the mountains, especially the north and west side. We're getting into, you know, the Blue Ridge and the Appalachians. So slope will have an impact on this study. For me, I'm using contour lines to create slope, and then creating that and then converting that over to raster so that it can be as well added into the previous raster layers. You can see my reclassification table over here. Minimum slope, you know, code of 3, and then very intense steep slope would get a code of -3. So it will negatively impact the potential of development. Step 4 is going to be buffers. And before, in the previous study, they talked about the importance of distance to important features of interest. And the way I'm going to capture that is through buffering these features and then converting those individual buffers to type code values that can be used in the raster calculation. Buffers closer to, distances closer to these features of interest will have a higher value, and the further you get away from those features of interest, you would have a negative value. That is, and I picked roads, city centers, highways, and services as the main features of interest because that's what we have to offer in Oconee County. I talked about water before. Water is a big part of the county, and so that buffering would actually be flipped, the values for the flood zones, because if the closer you are to flood zones, the less development is going to happen unless you really invest in it. I'm going to take those buffers, convert them to raster, and then using the distance to source values as the field of interest. Step 5, combining the rasters, using just a simple raster calculator to take all the different rasters, all, you know, that were originally the buffers, and adding them up so I can create a master raster, which would show, you know, each individual raster cell would have a, you know, either positive, neutral, or negative value, and that would correlate to positive would be potentially very high for development. we get to the neutral area that you're not really too sure. And then negative values would be there's a high potential of development not really occurring. And my hope is that taking all these individual little layers and information and adding it all up, it can give a really good picture to what there is for potential for the area. And that's why I used all similar kind of codes for reclassifying the rasters, keeping within a similar range, so that when you add it all up, you're going to be getting a certain value that you're expecting. Really good values would be kind of in the 15 to 30 range, and really poor values would be in the -10 range. Step 6, taking those rasters and converting them back into polygons. I do know that you're going to lose kind of really detail in this. When you convert to polygon, it's going to flatten out the data a little bit. But since my study area is the entire county, and we're trying to get a good general idea of what areas to look at for the future and what areas not to look at in the future, I'm just converting back to polygon, because then I'm going to add in different vector data sets to use for the future predictors. Step 7 is the current infrastructure. So I talked about there's all these different areas that I'm interested in. There's all these different features like roads and services, distances to those that I'm interested in. But I already have data sets that show potential growth. And I feel like these would be important to include as a last step to even highlight areas that already are highlighted with the previous analysis. So the regional sewer authorities and the municipalities both have their sewer system data, so I can see where it's existing. And that can be overlaid to show where there's already potential areas you can grow off of, because you're just extending existing services. And then on top of that, I have sewer service denied and sewer service requests. And that's just showing more of existing demand or existing areas where they could not service right now because they don't have the infrastructure to do it. So this would be an additional factor to pull out the importance of certain areas. And lastly, I talked about parcels. And parcels are really important because they tell you, who owns it and what the configuration of the land is. Working for the county, I do manage the parcel layer as well, so I can pull that in and use that to pick out particular areas of interest, especially for commercial growth, because in general, commercial development is going to favor large tracts of land. They're not going to want to go in and combine a bunch of parcels and then build on it. They want to purchase an existing parcel and build on it. So that would just be an additional area of interest to overlay large tracts of land, 25 acres, 50 acres, 100 acres of continuous land. And then if that is lining up with the predicted areas, that has good slope, has good proximity to roads and so forth, it would really be an area of interest to plan for the future. Expected findings. Areas of high density or development will be predicted to have little future growth. Areas of little development, fields, forests, and barren land will be predicted to have future growth. Areas near major roads and those other features of interest would have a high predictive score compared to areas further away. And then a list of parcels that have the potential for mass development that fit the criteria. Preliminarily, going through the steps, it's important to note that slope will really affect this study, especially in the northern part of the county. There are plenty of areas that it just won't have development unless you do massive land works, and that's not really in the equation for the next 10, 15, 20 years. Water bodies will affect this. Water bodies will easily cut out certain areas, wetlands and open water, because it's not an area for development. And then zoning and zoning boundaries. There's going to be areas that are protected. There's going to be areas that are going to be limited to a certain amount of growth. And so that's going to be a deciding factor for a lot of the study area. Project timeline. I'm doing my presentation today, of course. I am going to hopefully present at the South Carolina Environmental Conference in March of next year. And then from February to May, I'm going to be continuing this study and research into the 596B capstone final project class. These are my references to include my literary research and my references for the different data sets and previous studies. And these are my image citations. Thank you. And does anyone have any questions?
Great job, Nick. As a reminder, if you want to go ahead and speak up, you can unmute, or you can type a question in the chat. While people are maybe typing, Nick, this sort of takes me back to my job prior to coming to Penn State. I did a lot of work with, I guess, more sewer systems, not septic stuff, but also E911. So sort of as you were talking, I was thinking, it's a mostly serious question. How soon are you going to be able to hire someone to help you with your seemingly like 5 full-time jobs?
Yeah, so it's funny that you bring that up. I think I might have touched on this before. Yet there are 3 major GIS pros in the county, and I am the only one for the public. So I manage everyone from all the different municipalities, the water systems, the sheriff's office, all of that kind of stuff. And there's not a plan right now to hire someone. It's kind of all me.
Yeah, I did hear that. Impressive.
There was a point where this project actually got sidelined because I got pulled into a search and rescue where we had to do mapping for that, and I had to do that all over one of the weekends. So I love it. I love what I do. I love being able to help so many people. But overall, it's a younger county and it's a smaller county, so resources are limited.
Yeah. Well, very interesting project. It looks like Anthony has a question in the chat.
All righty. So I see Tim's question. Oh, Anthony, yes. So question from Anthony, do you have a plan for evaluating the success of your model, perhaps by comparing its results versus recent known development projects? It's a great question. That would be the next step, really, to do that. It is nice being in the situation that I am now, is because I already have past plans, the past developments, what's going on right now, and the future developments, 1, 3, and 5 years out. So I definitely will use those to test it, but I'm definitely not using those to do my initial predictions, because I want to use the other criteria first for the project. And then Tim's question is, you said this could be a baseline for further suitability plan. What other expansion readiness metrics could you incorporate in the future? So, like I said, the big thing about this area, and this actually goes for most of the infrastructure, it's a very responsive infrastructure need. Infrastructure is only really put in as the need is foreseen. So it would be nice to use this as a baseline for at least, sewer system, but future expansion readiness metrics, I don't have access to that right now. And as I continue on with this project and talk to more and more people about it, I would hope maybe I can find something else. And then the next question from Jim, your reclassification values, did you get those from the lit review or come up with them yourself? So great question. I did get the idea of the reclassification from the literature review. They definitely used a wider breadth of reclassification. just because I feel like they're trying to feed that information into I guess, the R AI program to predict future values. I stuck to a more limited breadth of those values, like I said, kind of a 5 to -5, just because I want every single point of, I guess, feature of interest to kind of influence equally, because I chose features of interest that I feel like already affect a lot of people, and they want to be close to these things and they want to develop around that. This project could have a future where I pull in more features of interest or pull in more predictors, that I would have to expand that breadth of the raster reclassification to encompass that.
Okay, great job again, Nick. If you want to go ahead and put your email in the chat as well, in case anybody has some additional questions.
Okay. All right, and then I guess I need to stop sharing.
Yeah, so if you can stop sharing, and Patrick Harrington is up next. Patrick, you can go ahead and start sharing when you're ready. I can see your slides, but I don't hear you yet, Patrick.
Oh, sorry, there we are. I had myself muted. Apologies
There
about
we go.
that. Okay, yeah, so again, hello everyone, good evening. My name is Patrick Harrington, and for my capstone project, I will be identifying critical nodes within a critical infrastructure network. So for tonight's agenda, first I'm going to start off with my professional background just to kind of give context as to why I chose this topic. And then I'm going to dive into the background of the study itself, and then followed up by the proposed methodology, the proposed data set I'll be utilizing, my anticipated results, the project timeline, and a possible presentation venue. All right, so my professional background, I served over 8 years active duty. I'm currently in the Army Reserves, and I served as a geospatial imagery intelligence analyst. This included 2 overseas tours. One of them supported Operation Freedom Sentinel and Resolute support in Afghanistan. And the other one was Operation Juniper Shield, which was a combined joint task force in Africa fighting against Islamic terrorists down there. And I supported Nigeria through that. And a quick fun fact, I actually got to meet President Obama's dog, Bo, back in 2012. And I know what everyone's thinking. And no, that's not me in the picture. That is my mom's friend's son. I'm a little bit taller than that. I'm about 6'1", and I'm not also a toddler. All right. All right. So, as I stated, I'm currently a service member, and for me, national security is something I care deeply about. I want to live in an environment that is safe, that my family and friends and loved ones can live in safely, and also my fellow countrymen and allies. And during my time in the Army, especially in recent years, my commanders and senior enlisted advisors, they constantly tell us that, the battle space is changing. It's not going to be so much focused on land, sea, and air. We're going to be transitioning over to the cyber realm. And we have seen, conflicts are becoming more advanced as newer technologies are developed. We can see in, Ukraine versus Russia, how Ukrainians are using commercial off the shelf drones and attaching mortars to them and flying over to Russian armored vehicles and, fighting them at a safe distance, or, state or non-state actors, cyber actors, targeting social media networks and creating disinformation, and that, just dividing their target's population. So due to the fact that, society has had a mass integration of technology in our lives, as I stated, state-sponsored and non-state cyber actors, they now have opportunities to take advantage to compromise systems that, may pertain to national security, individuals' medical, financial, and personal records. And that leads us into critical infrastructure. So critical infrastructure systems are vulnerable to damage from multiple through multiple ways, right? So natural disasters, tornadoes, hurricanes, earthquakes, and component aging, because a lot of critical infrastructure, they were mostly constructed before today's cybersecurity standards. So, as let's say parts of a nuclear reactor are failing, they have to be replaced in a mannerly time, or else, that could not bode well for the local communities or regions of the country. Also, an increase in demand. So, as I stated, as there's these conflicts that are happening around the world, it's displacing a lot of people. So these immigrants are, trying to find a better life, but they also have the right to live safely. So, having a roof over their heads, having electricity, running water, food, and this influx of immigrants puts a strain on critical infrastructure. And then, of course, climate change kind of plays into the natural disasters and terrorist attacks, either through state-sponsored or non-state cyber actors. So identifying critical infrastructure and knowing which areas are key to defend, it's crucial for national defense. So the reason why is because we all know, governments have a lot of problems to deal with. So, whether it's homelessness, providing education, child hunger, whatever it may be, no matter what region you're in, governments have to find a way to fund and provide for certain programs. The same thing can be said for defending critical infrastructure, because some of these networks are so massive, such as the subset of the American Power Grid, which is the data I'll be using for this project. We have to be able to identify the main critical nodes to be able to provide the funding to defend them. Because if those nodes go down, I mean, that shuts down the whole system, and then we're reacting to emergency services to provide aid, or how long is it going to take to repair. But if we're able to identify these main critical nodes, we don't have to worry about attacks for nodes that may be a part of the network but are so far removed from the main critical node. If they go down, it's a lot easier to repair those and get power up and running again. So, as I stated, my idea is to work with the American Subset Power Grid, and through my through my literature review, I've identified popular algorithms, and what I'll do is utilize these algorithms to see which one identifies critical nodes the most accurately and efficiently. The first algorithm that I identified is the global structural model, and this consists of self and global influences. I then identified the local and global centrality, and this centrality concentrates on both local and global structure-based methods. The third algorithm I found was the communication probability and relative entropy, an improved technique for order preference by similarity to ideal solution, or CPR TOPSIS. And what this algorithm does, it emphasizes the importance of each node in the network, and then is evaluated from the view of global, local, and location information dimensions, and ranked through the weight TOPSIS. And then finally, I identified the HIC centrality, and this centrality is composed of the H-index, K-shell iteration factor, and clustering coefficient. Also, alongside these algorithms, I'll also be using some rudimentary centralities, such as betweenness centrality, closeness centrality, eigenvector centrality, degree centrality, and a few others to create a baseline against these algorithms. Because through my literature review, I noticed that each one of these algorithms were baseline against the rudimentary ones, because those centralities are just the baseline centralities in node identification. So for the first algorithm, the global structural model, these are the steps, and this is the workflow for this model. So first, you want to construct the network, which is just gathering data for real-world data set to identify the complex network. I've already done that by identifying the American Power Grid subset. After that, you want to calculate the global influence and then the self-influence, and then multiply those together, and that will be the global structural model, the total influence. And the greater the influence, the higher the ranking of the node, which means it's, the main critical node. Next, we have the local and global centrality. So this one's a little bit different. So the global structural model, the GSM, uses or calculates the self-influence, while the local and global centrality calculates the local influence with the global influence, local with the global. And then same thing applies. You multiply the local, the global influence, and then that is the local and global centrality. So the CPR topsis, this one's a little bit more lengthy. The first step is to create a decision matrix. And to create the decision matrix, the network normalized correlation matrix obtained that is identified is used to replace the traditional binary adjacency matrix. This transforms the original network into a weighted network that can better portray the relationship between the pairs of nodes. And then step 2, once we create this weighted network, through creating the decision matrix, we want to normalize it. And then we calculate the positive ideal solution and the negative ideal solution. And then we want to determine the weight of each criterion and then compute the distance from the positive ideal solution and the negative ideal solution. And then the second and final step is obtaining the relative closeness to the ideal solution between the positive and negative. And then once we find that ideal solution, we want to rank all the alternative solutions in an ascending order. And then the final algorithm is the HIC centrality. So as we're calculating potential edge weights, these edge weights are going to be calculated from the 3 aspects of neighborhood, position, and topological structure. Once we identify the potential edge weights, we will calculate the HIC centrality. And the reason why, when I was doing my literature review, I picked this algorithm is because this proposed method has a low computational complexity and can be used for sparse, large-scale networks. And something such as, identifying the critical nodes within the power grid system. I mean, there's thousands and thousands of nodes. So, the fact that this has low computational complexity means this algorithm can run iterations at a faster rate, and it's made to be used for sparse, large-scale networks. So my proposed data set, as I stated, I'm going to be using the American Power Grid subset. I obtained this data off of OpenStreetMap. As of now, so it shows the entire country, the continental United States, the entire power grid, but not every single node is on here due to national security reasons. I don't think it'd be very smart of the government to put every single piece of critical infrastructure on an open source domain. So this one specifically, I tried to choose a populated area. So I chose the Mid-Atlantic, more or less the Eastern Seaboard from Boston, Massachusetts, all the way down to South Carolina, and a little bit of Pennsylvania and New York in there. This current crop of points currently consists of 3,307 points. And now, depending on how these algorithms run, I can either add nodes to them or take away nodes. So we can do the entire Eastern Seaboard all the way from Maine down to Florida. We can include the Southern United States or even all the states east of the Mississippi. Very flexible, but that's going to be more of a reactionary thing that I may have to do depending on the results of the iterations of the algorithms as they run, identifying these critical nodes. So for my anticipated results, so through the literature review, CPR TOPS is ranked first in speed and accuracy when utilized against local and global centrality. So through that research paper, they ran those two together among the baseline centralities that I talked about earlier. But however, all 4 of these algorithms I found have not been tested against one another. But since, from the CPR TOPS research paper, it was first, I believe it should remain as the most effective algorithm. However, these algorithms have not been used in a geospatial sense. They've been utilized, analyzing social media networks, which is like hundreds of thousands and millions of nodes. So, I'm interested to see if there's any interesting geographic patterns with each of these algorithms. And I want to assess the distribution geographically through analyzing maps. Once I identify these nodes, plot them on a map, and then start understanding how these nodes are identified and where they are geographically within this region. And as I stated, since these nodes haven't been used in a geographic sense, I'm not sure what the results will be. I'm very excited to see what will happen, but I do expect there's going to be differences in the locations of the critical nodes through the results of the algorithms. So for my project timeline, tonight, October 23rd, 2023, I'm conducting the proposal. And then mid to late summer next year, probably around July to fall 2024 and into 596B, I'll be conducting the analysis, running through the algorithms and the iterations, messing with the data set and plotting them on a map. And then what I plan on is in November of 2024 to present at a conference during GIS Days 2024. So I'm not 100% sure if GIS Days will be in November 2024. It's currently for 2023 will be next month. But the reason why I chose GIS Days is because it's a worldwide celebration of GIS, and there's a lot of conferences that are taking place within the National Capital Region where I'm located. And since my project has to deal with national defense, I believe that it'll be beneficial to kind of show government workers or advisors that, hey, here's something we kind of need to worry about. Here's how these algorithms can do this. Start thinking about defense or creating our own algorithms if we want to be on the offensive against other countries. And with that, this is my works cited. If there's no questions, then this concludes my presentation.
Great job, Patrick. Does anybody have any questions? You can type them in the chat or unmute and speak up. And like you said, I think that you'll probably find lots of GIS Day conferences or events to present at, but you're certainly welcome to come to Penn State's event if you can't find any others.
Oh, absolutely. I would love that. Yeah.
Yeah, so just let me know and we can make that happen.
Okay.
Any questions for Patrick?
I have not. That is that's something I should look into.
If you can read the question, Patrick.
Yeah. Oh,
just
sorry. Yeah. So it says, nice words, Patrick. Have you taken a look as well at DHS's HIFLD infrastructure data? And then there's a link to it. So I haven't looked at it yet. Well, since this is my first time learning about it. I wanted just to focus on one type of critical infrastructure. I believe that this study using these algorithms can be used against other types of critical infrastructure. I think if I use multiple kinds, it's just going to muddy up the results. And what I'm mostly looking for in this study is how these algorithms work. So, for instance, for me to see if they're effective or not, if these algorithms, like let's say there's 3 of them that constantly through their iterations identify the same critical nodes, then I know that these are working. So mostly what I want to see is how these social media created algorithms can be used for geospatial purposes. But absolutely, I'll take a look at that link and see what I can find there. Maybe just add more. Yeah, if I need more data or try to diversify it a bit, if that's the thing I want to move forward with, then for sure. And then, yeah, Anthony also stated this additional data, and it's been a while since I worked with that stuff, but I would take a look at recent conference talks to see what people have been doing in public presentations with HIFL data to examine critical infrastructure, maybe some good inspiration in that work. Absolutely. No, good point there. I will absolutely look into it.
Any other questions for Patrick? There's one from Jim.
Yes. So Jim asked, is evaluation of these algorithms going to require you to write your own scripts, use existing scripts? So yes, utilizing these algorithms will require me to write my own scripts. I plan on using Python and RStudio for them. The rudimentary centralities, those could be done through Node Excel because they're a little bit more simpler. But since these are more complex, absolutely. And then use loops to run through the iterations. So that's going to be a big kind of movement or part of the project for me is to make sure I can write these scripts and make sure that they work properly.
Okay, great. Well, Patrick, if you want to put your email address in there in case anybody does have some additional questions they think of.
Absolutely. I just got to find my email address. I always forget what it is for Penn State.
There we go. Very good. Thank you.
Mhm.
And it looks like you had Jim for some programming classes, so you'll be well prepared.
Absolutely.
Okay, well, thanks again for a great presentation. Looking forward to hearing how everything works out. And if you want to go ahead, yep, perfect,
Nope.
stop sharing, and then we'll get to our last presentation of the night, Nicholas Tate. And Nicholas, whenever you're ready, you can go ahead and start sharing. Oh, Patrick, it looks like you may not have stopped sharing yet. Patrick, were you able to stop sharing? Or Nicholas, are
Yeah.
you able?
Yes, I stopped sharing.
Okay, Nicholas, are you able to start sharing? Actually, Nicholas was in here earlier, I thought, but I'm not seeing him now. I see Melissa, his advisor, in here. Hold on one moment while I reach out to him. Thanks, Melissa. I just left a message for Nicholas. We'll see if he gets in here soon. Thanks for your patience, everybody. There we go. Hi, Nicholas. We just are a little ahead of schedule. So whenever you're ready to start sharing, you can go ahead.
Great. Hi, everybody. Can you hear me okay?
Yes, we can.
Okay. So best just if I just share my screen.
Yep, you should be able to hover over the bottom there and be able to share your presentation.
Okay. Let's see. How's that working?
Looks great.
Great. Okay, just give me 1 second. Okay. Hi, everyone. My name is Nicholas Tate, and let me get rid of this. My capstone proposal is titled Variation in Carbon Stocks by Forest Ownership and Protected Area Type in the Coterminous United States. So why have I chosen to look at forests? Our planet is warming at an alarming rate. Climate change is threatening to impact life as we know it in our world, and forests are crucial in the fight against climate change and for climate change mitigation. They sequester more carbon dioxide emissions than any other land use type, such as grasslands or agriculture, and they actually are the single most important land type for carbon storage or sequestration, which means the same thing. So there's that reason, and I also have some prior experience with the subject. In 2021, I was a research assistant for a soils professor at the Yale School of the Environment, and I spent 6 months collecting soil samples and leaf litter samples in forests across the United States, and then measuring carbon emission from them in the lab. And my work was part of an ongoing research project looking at carbon feedback cycle between below ground and above ground in eastern forests. And then I did another 6 months as a GIS assistant for the same team and mapped various different forest carbon data sets. So it was a subject I was familiar with and I wanted to dive more into for my capstone. So how do forests store the carbon? They sequester carbon by capturing the carbon dioxide from the atmosphere and transforming it into biomass via photosynthesis. It's a process I'm sure many are familiar with. I have a little graphic showing sort of the cycle of forest carbon. And it's typically stored in carbon pools. That's where carbon is kept within forest, and they're defined. 5 different are defined. Above ground living biomass, which includes the trees, the leaves, limbs, trunks. And then the below ground living biomass also stores carbon like roots. Then we have dead wood and litter on the forest floor and soils are all storing carbon. Okay. And then that carbon is stored in a somewhat stable form generally in forests. And disturbances are how it's released into the atmosphere when it turns into emissions that can compound global warming. Some of these disturbances are naturally occurring, like decomposition of dead wood from dying trees, or certain forest fires that are naturally occurring. But there also are human-caused disturbances, like development, clearing land for agriculture or buildings in urban areas that will permanently lose that carbon sink, and result in more carbon in the atmosphere with less carbon being taken from the atmosphere. Logging as well can release carbon into the atmosphere, but sustainable practices should keep forests as forests, and as trees are taken, they're also still growing, so they can continue to store carbon. And in addition to that, forest products like furniture and hardwood floors continue to store carbon for years, sometimes even more than the trees themselves would have. So there are sustainable ways to do it, but when forests are changed permanently and that land type is changed, then that's when we lose that carbon sink. So forests in the United States cover approximately 33% of the country's land, and that's almost 766 million acres of trees, storing over 866 million metric tons of carbon per year. And America's forests offset about 16% of the nation's domestic carbon emissions per year. So they're very important when it comes to storing carbon and helping mitigate climate change. And obviously there's a bunch of different types of forests as you get to different ecological zones. The Forest Service recognizes over 400 different tree species spread across our landscape. And trees like red maple and balsam fir dominate the sort of northeastern area, with loblolly pine and longleaf pine in the southeastern area. And then lodgepole pine and red alder is like more prolific in the Pacific Northwest, and these are like the 3 sort of areas that really store a ton of carbon. They're probably most important to think about. So these forests that cover 33% of our land in the United States are owned by a variety of entities, both public and private. the US government, federal government owns 238 million acres, 31% of our forested land, and the remaining 69% is non-federal and predominantly privately owned, but that 69% does include state and local governments like counties or cities. But the forest ownership could have an important influence on how forests are managed to maintain carbon stocks. So I'll get more into the specific categories of these different types of ownerships. That's sort of what the whole point of this capstone is going to be about, but a lot of different entities sort of at play here. So I did look at a study. I found a study on forest carbon that was done on forest carbon in protected areas. So PAs mean in Uganda, and this is from Gizachu et al. And they measured forest carbon gain and loss for 713 protected areas in Uganda over a 12-year period from 2000 to 2012. And they found that carbon gain and loss varied significantly between the different management categories of the protected areas, and that forest degradation and development threatened carbon sink potential. And they determined there's an urgent need to look into protected area management techniques and to improve protection if Uganda is going to benefit from carbon conservation and climate mitigation mechanisms like REDD+, where they could receive financial or technical support for reducing their emissions and storing carbon. So this study is relevant to me because they're looking at sort of forest carbon gain and loss for protected areas, and it's sort of finding variation between different types of protected areas, and that's something I'm also potentially going to be looking at. And those are sort of findings that can inform policy. So for my goals and objectives of this capstone, I want to examine forest carbon stocks in different types of protected areas in the United States. I aim to look at the distribution of forest carbon across different ownership types, just for the contiguous United States. And I'll introduce the data sets a little later on, but I'm going to be looking at the different types of ownership for both private and public ownership and protected areas. And I want to sort of visualize how the forest carbon levels vary between all these different types. Unlike the study from Uganda, my analysis will be temporally static. So I'll be looking at forest carbon stocks just for the year 2017, just to sort of get a snapshot of the data. And that method will give me a look at sort of the most recent data that I've found for forest carbon that I'm going to be using, and just sort of see how it looks recently. Yeah, so the research questions that I'm going to be sort of answering as I look to sort of analyze this data is sort of how do levels of forest carbon in publicly owned forests compare to that of privately owned forests, in which ownership type has the highest amount of carbon, which has the lowest. How do carbon stocks compare between protected area forests, like fee and easement? And again, I'm going to get into those definitions a little later. Are there any discernible patterns of level of forest carbon stocks when compared to different types of ownership? So really just looking at how the forest carbon stored in our forests is spread across these different ownership types, and what that could mean for how protected they are, how protected they aren't, and where we might need to look at making interventions. So the data sets that I'm going to be using for this analysis that I've identified so far are from you et al., the forest carbon data that you see in the photo right here. This is visualizing 2017 above ground live biomass as a raster, and I will focus specifically on the 2 of the 5 forest carbon pools that I mentioned, the above ground living biomass and the below ground living biomass, as those are the 2 that are the most sort of at risk for losing that carbon sink, because that's the actual tree. Soils and deadwood and stuff are sort of already in a pretty stable form. So when you have disturbances that disturb the forest, you're gonna lose the living biomass and the above ground and below ground living biomass. So this includes trees and shrubs and forbs and grasses and sedges in the forest and roots. So in the data set from you et al. From 2021, they estimated forest carbon stocks using a modified max-ent model and satellite imagery combined with forest inventory and analysis data. And the data files are rasters at 100-meter resolution, and have each carbon pool, not just the ones I'm going to be using, and from years 2005, 2010, 2015, 16, 17, but I'm going to focus on 2017 for my analysis. And the two other data sets are the SAS et al. Forest ownership data set and the USGS protected areas data set, which I'll get to in a second here. So from SAS et al., From SAS et al., we have forest ownership types. And those are defined as public and private. And then within those, there's subcategories. So for public, we have federal land or forests owned by the federal government, state government, and local government. And then for private, we have family, which is owned by families, individuals, trusts, estates, etc. And then corporate and the timber investment management organizations or real estate investment trusts, which are really just companies that own timberland and broker logging deals. And then other private, which could be conservation organizations and unincorporated partnerships and associations. And then obviously there's tribal land as well. And the other data set that I'm going to be looking at is the protected areas database from USGS. And they are not specifically focused on forests. They have protected areas for the data set has protected area vectors for the whole US. And those are split into fee, which is land owned outright, the most simple type. Land owned outright by public agencies, nonprofits, and private entities. And then easement, which are conservation areas provided by the NCED, where legal agreements have been set between landowners and eligible organizations to protect the land. And then designation, proclamation, which includes the tribal lands, military lands, and then marine is obviously protected waters, which won't be included in my study. And these protected areas are defined as areas dedicated to the preservation of biological diversity and to other natural recreation and cultural uses managed for these purposes through legal and other effective means. That's how USGS defines them. So I'm curious in how I'll look at how forests are protected and look at the carbon within those forests, within these different types of protected area. Yeah, and that's going to be part of my proposed methodology, is to determine the spread of forest carbon. I'll bring in a county layer too for US counties. So I'll just sort of do it at the county level and just sort of see how the spread of forest carbon looks across the contiguous United States between these different types of protected area and forest ownership. I plan to analyze the levels of forest carbon present in these different types of forest ownership, and within the protected area data set, I want to also break it apart into federal protected forest land and nonprofit forest land and private forest land, and just sort of see how forest carbon levels vary between those different types. Same thing with the SAS et al. Data set as well, with family ownership types. Yeah, and I just wrote down some of my proposed methodology using ArcGIS Pro. Something I did a little bit of already, but basically I'll use different geoprocessing tools like the CLIP tool and zonal stats to sort of combine my protected areas and family ownership vectors with my raster forest carbon and get sort of total sums of carbon per county and join those tables back and sort of get an idea of which counties have the best levels of protection for different types of forest ownership and protected area. And then I thought I would also maybe run some statistical tests to see any correlation between forest ownership type and carbon stock. And I actually have done a little bit, something kind of similar for a previous class with conservation GIS, where I use a similar methodology, similar data sets, not the same. I did use a protected area database, but I did I used the combined of, so this like fee, easement, all of them combined into one. This is a simpler look at it, and focused only on the Northeast with a different forest carbon data set, and just mapped the percentage of forest carbon within protected areas per county. So you can see where there's a lot of protected forest carbon and there's not a lot, and where there's not a lot of protected forest carbon. And so I envision my sort of final map products for this capstone to be sort of similar to this, but for the entire coterminous United States with various different types of sort of more detailed look of protected areas type and forest ownership type. Yeah, here's my rough project timeline that I outlined between now and March 20th, when I'll be finishing up 596B. And then, let's see, just a quick look at that. And then presentation value. I think my research will hopefully benefit, the many stakeholders that surround forest management in this country, which includes, the managers of all the ownership types that I sort of analyze: federal, state, local governments, family owners, corporations. And they'll be able to see sort of where the forest carbon exists in this country, and how sorry, one second, my notes are getting messed up. How they might be impacting levels of carbon in their forests, and how their management could be, if they have low levels of forest carbon in their type of management, maybe they can take a look at how their management is impacting that stored carbon. And I also think that, policymakers and political leaders would be interested, and investors in the sort of forest carbon economy might be interested in where the forest carbon exists in this country, and within which types of forest ownership and protected area it's doing the best and has the most and highest stock. And obviously, I think it would be significant to the future of science, because it's gathering information about forest carbon storage, which is super important to climate change mitigation and global warming mitigation. And hopefully this sort of research will contribute to our understanding of how ownership of forest carbon is spread across our country, and where there might be need for management improvement. And then, it falls within the realm of my own personal career aspirations. I've enjoyed an early career of working on forest monitoring teams, collecting field data and samples, and helping map sort of forest carbon and forest monitoring plans. And after years of working sort of on the ground in the field, I'm sort of eager to combine my passion for forestry studies and conservation with recently developed GIS skills. For anticipated results, I'll have to sort of, wait and see. I'm not really so sure what exactly will happen. I think forests managed to remain as forests will likely store the most carbon. So I expect that public lands will likely have high amounts of forest carbon stocks, as those typically have very strong management plans. Private lands, I expect to see a mix of areas with high and low, as people have different purposes for their private forests. Some will manage them to protect carbon and conservation, and some will develop them for logging or anything like that. So I think it's going to be a mix. And then easements, I also would expect to have high levels, as those are for conservation purposes. I should also recognize there's a few limitations off the bat that I can see, like forests that experience fewer forest fires and destruction from pests or diseases like emerald ash borer or something like that would also have higher levels of forest carbon. And that's not something that I'll be looking at specifically in this project with this scope, but forest management practices that minimize those stressors obviously will do better than forests without as much protection in place. But yeah, I excited to see where this leads, and that is the end of my presentation. So thank you.
Good work, Nicholas. While we have, well, if anybody has any questions, feel free to either speak up, unmute, and ask your question out loud, or type it in the chat. And Nicholas, I was just wondering if you and Dr. Kay are planning to publish or to present at a conference.
Yeah, I think we talked about maybe having it be on her Penn State Extension site for sure, and we'll have to discuss the conference thing. We're not,
Okay.
I don't think we've identified one right now.
That sounds good. I really like the personal career aspirations part of this, and I also look forward to seeing how it turns out. Do we have any other questions? I guess one possible presentation thing would be the PAGIS conference. I know you're in Maryland, but I'm not sure when their state conference is, but those are always some nice venues. If you're not able to find, sometimes it's hard with the time frame because it sounds like you're going to be graduating in May.
Right. I feel like it's a lot in the fall, right?
Yeah, but I'm happy to help you guys find something as well if you would like it.
Yeah, that'd be great. That'd be great.
Thank you. That would be great. Yeah, we have opportunities with the Society of American Foresters. I regularly attend those conferences. And then we have the Association of Natural Resources Extension Professionals. So that's extension education. And so we're always looking for new ways to describe our forest resources. So I think this will be a great way to kind of break down the carbon and climate potential of forest lands too. So
yeah, that sounds fantastic. Those all sound like good options. Any questions? It's always hard to be the last presenter. There, Jim has a question.
Let's see. Yes, yeah. So all the ownership types are forest. So anything that, corporate, private, family land is all going to be forest with trees. So the difference is going to be whether or not they're using it for, to keep it as forest, or whether they have other plans for it. But the snapshot will be from 2017. So whatever it was in 2017 is what I'll be looking at for right now. And the answer is yes, that it's going to be wooded land.
Just to add a little interesting perspective, family forest ownership or individual ownership is one of the largest categories of private forest land ownership in the United States. So it's it seems like a pretty straightforward category, but since I work in this space, they're pretty heterogeneous. There's a lot of diversity even within that category. So yeah, this is an interesting space to work in, definitely.
Yeah, which is going to make it interesting to analyze, because I think that'll also be a slight limitation, is that I'm not going to be able to dissect the family layer, like feature, as much, because the data doesn't have that. The data set doesn't have that information as much of how they're using their family land. It'll just be family land, which can be used tons of different ways.
Yep, I agree. Yep.
Yeah, I was thinking about that as you were talking about the different categories as well. And I'm sure these are probably very small areas that I'm thinking of, but do people ever pass that land on and, donate it to, I don't know, state land or federal land or anything like that?
Yeah. And easements. Yeah, no, they do, but there's still a ton of it in private ownership anyway.
Yeah. Very interesting. Well, thanks very much to both of you.
Thanks, guys. Yeah.
Sounds like a great project. And Nicholas, if you want to put your email address in the chat, that'd be great. There might be some other questions that come your way.
Sure.
So for everybody, I did put the peer review evaluation form there, the link. And so if you can fill out an evaluation for everybody who has presented so far, tomorrow we will start again at 11:30 a.m. Eastern. We will have 3 presentations tomorrow, and we will have 4 presentations on Wednesday. So it's 11 total. But thanks again for everybody to come tonight and to ask good questions, and look forward to seeing you tomorrow. Thanks, everybody.
Thank you.